Well, we're back, and this is Unit 1.5. This is the last unit in Unit 1, or I should say last section. So what we're going to do here is we're going to look over casting, like we said before. We're going to touch on casting a little bit later, but this is a little bit later. And then we're going to also end off with the range of values. And through it all, we'll have a few examples, and we should be checking these things out because the first assessment, which is the first unit quiz, is going to be touching on all these things. So let's begin. So first of all, we're going to go back to what we had before. I'm putting a little highlight here. Cost is a double, right? It represents money, and value was an integer. And back then I said you could not assign a double to an integer unless you cast. And here's what we're doing. Right now we are casting. How do you cast? You put in parentheses the type that you want to turn this into. So right now I want to turn a double variable into an int. So the cast in front is what I'm going to. This cast is a narrowing, you must remember, because we're going to lose some data, decimal portion. Cost was $19.99. After casting, it will become 19. Okay, it's not a rounding, it's casting. It's literally just delete the decimal. We're going from 8 bytes down to 4. That's why it's called a narrowing. And we said that before, and I'll say it again. If you're doing a narrowing conversion, the programmer has to do that. Why would the system not do it automatically? Because you're going to lose data, and it doesn't want to be responsible for that. If you're going to lose data, the programmer has to be perfectly clear that you're going to be losing that 99 cents in this example. This second one, cost, being the on the left side here, the value was an int, and we were going to cost, which was a double, and this cast is what happened automatically. So you see I had automatic cast. We said this one is a widening because we're going from 4 bytes to 8. So if we're going from 4 to 8, we're getting bigger, so it's widening. This one happens automatically. What do I mean by that? I could take this off. Okay, I could take this off and nothing is wrong. The system does it for me. So even though you don't see it, it's there. I'm putting it back. If I take this off, however, something is wrong. You see the error right here. So we can't do that. So even though you have a type here and it's different to the type here, sometimes it's possible that the system will do it for you. Generally, that's a widening conversion where no data is lost. So here we have a few examples. We have example 11, 12, and 13. We'll take a quick look at these to round off this unit 1. So here I have two variables, q and m. They're both doubles. Now you realize I'm assigning an integer, right? To a double, I'm assigning an integer because 2, isn't it? I should be doing 5.0. But in this case, it's a widening. So it's perfectly okay. So it's a widening conversion. I could actually say, you know what, I'm not going to let you widen anything. I'm going to just assign the right type. So we got to keep those two up there in mind. Now, this little arithmetic expression here, we got to evaluate. And then there's a cast at the end. So let's begin. Remember, these are doubles. So parentheses first, order of operation. So we're doing 10 times m. M happens to be 2. When we do 10 times m, it's going to be 20.0. Remember, it's a double. Okay, so 20.0 will be here. The next statement that needs to be done is this guy right here. Okay, so q divided by m. So if we have q divided by m, we'll do 5.0. Okay, it's going to turn it into that. Divided by 2.0. Okay, so that'll be 2.5. So you have to walk through all of these and do your order of operation and see what the final solution is going to be. Okay, we'll run this in a second to find out what that answer is. But let's just keep going on. And then after you finish doing that division, then you have to do this multiplication, order of operation. Then you got to go to division. And then you have to do the addition and then so on. Okay, this is something we did in intro, so you should be able to find out this. Just know that when you finish with all these double and you get an answer, you have to cast it to an integer. And right now, if you cast it to an integer, we want to see what would happen. Okay, so let me run this and check it. Okay, so right now, I'm looking at the answer being 0.0. How is that so? Well, whatever answer you get here, if it happens to be a decimal like 0.5 or something like that, I didn't do the calculations, I'm going to leave that up to you to do. If it comes to 0.5 or 0.3 or 0.8, it's going to end up being 0 because the decimal portion is going to go away. But you got to remember, even though I cast it to an integer, I'm assigning it to a double. See, you gotta pay attention here. So yes, I do that, turn it into an int, but then the widening that happens automatically turns it back to a double. And so yes, I got rid of the decimal and then I go back to a double. So it's going to be whatever 0.0. In this case, it turned out to be 0. Example 12 says, run this code and see what the D is going to be. Okay, so A and B, you must remember these were integers, okay? We know that because there was an A, B, and C in an earlier section, and we are using them again. In this case, I'm changing the value of A. I think the value of A ended up being 6, if I remember well. We're changing it to 4, and we're changing the B to 5. Now, once we do that, these integers are going to go in here. So we got to be careful here. 4 plus 5 is 9. 9 divided by 2, you may say 3.5, and I'm going to say you are incorrect. Well, I shouldn't say 3.5, I say 4.5. You may say 4.5, and then you're incorrect. It's not 4.5 because these are all integers. So even though math.square-root is going to return a double, this is called a static call. I'm going to make a little note here. This is called a static call. Just in case you're wondering, what does this static in main means? Public static void. Static call simply means the name of the class dot the method. Okay? If it's a non-static call, we have to do math equals new math. We have to create the instance of the class, the object, and then use the object's name to call it. Static calls don't do that. You just go straight to the class and dot method. So yes, this is going to be 9 divided by 2 is not 4.5. It is 4. So when we take the square root of 4, it returns 2, not 2, 2.0. It's a double. And example 13 is talking about how can I use this information of casting to round. Now, this is something that you don't necessarily have to do, but it could be done. So if the value is a positive number, just add 0.5 and then cast it, and you've rounded up to the nearest integer. And if it's negative, you subtract 0.5 and you'll be rounding to the nearest integer again. These are two things that you should pay attention to. Oh, by the way, look at this little statement here that says s equals to negative s. So we're just changing the sign. And we're doing that just to show these. I'm going to run this again just to show you. But just before that, let's wrap up with the last piece, the range. What's the biggest number or the largest number that we can hold in an integer? And what's the largest number we can hold in a double? And what's the smallest number? And I'm speaking of the negative version of that. Now, you could definitely say 4 bytes. Okay, that's 32 bits. Write down 32 bits like we did in intro and put a 1 in every spot. And then go 2 to the 0, 2 to the 1, 2 to the 2, all the way up. And then add them up and figure out what that number is. Or you could make a static call. Here we go again. Okay, integer dot. Okay, this is a static, and this value here is a constant. How do I know it's a constant? It's all uppercase. You could see, and it's an underscore. We did this earlier. Okay, we did this earlier. So when you see these things, you should like say, oh, that's from the API. It's a constant. I know it's all uppercase. And they do normally use underscore. That's why I did mine as well as the underscores. So these values here are in the API. You don't have to figure them out. You could just simply call them. But then these are static calls. These are not integer x equals new integer. No, we didn't do that and they say x.max. We just say integer.max because these are constants, not going to change. Now, I'm going to run this. We're going to take a look at all the outputs to see what we got. We already know the first one had a 0. And again, this is from everything that we've done in Unit 1. So I'm going to scroll right down to the end. Now, the last thing that happened was the maximum value for a double. It's 1.79, a long number, e to the 308. That's a big number. That's a big number. And then we have the minimum value being right here. And we have the minimum value. Just realize that it's just a negative and a positive version for the integers here. Okay, smaller and the bigger. And then we have this these values over here that were rounded as this one was a print and not a print ln. So we had this weird situation happening here, obviously. So because we have the 6 and negative 6, right? So the 0.5 make this go up. So we rounded up to 6, and we rounded this as well down to negative 6. But because we didn't have a print ln here, it turns out to be like 6 minus 6, like as though we're doing some sort of a problem, but that's not a problem. That's just because the print did not have an ln, so we didn't drop to a new line. I'm putting all this in there because I wanted to think about these things, even though we're in the last section and we've done this before. Got to keep reminding yourself about these things because questions like that are going to show up and you're going to have to pay close attention. Did it have an ln? Did it not have an ln? Did it have a backslash n, so we went to a new line? Pay attention to all of those. So this is pretty much the end. We finish in section, and again, this one, remember this one was supposed to be 2.0, just going back, and the one up here we knew that was going to be 0. You have to do the math for this and see what number it comes out as and then cast it. So we're finished with section 1.5 now. You're going to have all the videos are going to be posted and the notes are going to be posted as well. So if you're finished with this one, welcome again to computer science and congratulations, Unit 1 is a